Let's write the same program with a little modification. Y equals 0, while y is less than 5, y plus plus. Print ing_src plus y plus JPEG. Variable I is of the same initial value and whilst condition is the same. While is followed by 2 more lines, not one like before. If we want more than one statement after while to be executed 5 times, as in our example, we have to use the curly braces to let the compiler know. We know by now that ++y increments variable y by 1 before touched. Y++ increments variable y by 1 after the statement it is called from is finished. So we don't have a file called 0.jpg, thus we wanted I from its value 0 incremented before the computer tries to display picture. We saw 2 possible solutions. Y equals 0 while y is less than 1, print y++. By now I expect you to know what this program does. Or try and guess it. Also, y equals 0 while I is less than 1, print ++y. Both programs say 0 is less than 1, so the next instruction should be executed. First time print 0, then I becomes 1. The program will finish its running on the next evaluation, that is, 1 is not less than 1. The second program prints 1, then I is equal to, so while we evaluate to false. Take away the keyword print and you're left in both cases with a really simple but important structure. If a condition is evaluated to true, it will run, otherwise it won't. It's maybe even more common than loops. It's the if condition. If do something. So, while originally had to have a variable for our purposes, the if condition doesn't necessarily. We spare 1 line and 3 letters. How cool! But it's not a loop, so it only executes once. Hungarian notation or camel case is what we call the thing, how I spelled do something. Here's another small program. Y equals true, while y, print y equals false, print y. Do you know what it does? Stop the video here and think of your answer. So we have seen that a variable can have a value of an integer, but actually there are variables for Boolean values too, that can contain the false or true values. Since we want 2 instructions to be inside the loop, using curly braces are necessary. It will write true. Later on, when it exits the loop, it will write false. Now you might have noticed that I used braces after print this time, and at a later point I omitted them. It's just language dependent. Some languages make it possible to use both, and others neither. They use words like write instead or printf, and actually it's more of a naming convention. C++, for example, prefers cout, as in C, out, instead of printf, which is heavily used in C. Java changed cout to sout, as in system out. Actually it uses system.out.print, but the programming environments make it easier for us. If we type sout and press tab in NetBeans, it will be converted to system.out.print. So you see, most of the programming languages differ from each other in their naming conventions. If you learn 2 or 3, you might have a good chance of understanding code written in a 4th language. A smart guy said the most difficult thing in programming is giving things names. You couldn't believe how much effort, time, and thus money is spent on it. The reason is that we want to write reusable code in every possible way, and when we write code, we write it for others, not for ourselves. Others will be reading it, they will have to understand. Nowadays it's different, but in the early days programmers used to be mathematicians, so lots of expressions in science are borrowed from math. Variable is one of them, function is another. First we had to keep track of some value, so we use variable I for it. Most languages actually specifically require us to create these variables before we can use them, assigning some type to them. Their type can or cannot be changed later, depending on the language. You will see the keyword int a lot. It abbreviates integer. So far, when we were using while loops, I was assuming that a variable was created somewhere above, or depending on the language, it will be created automatically. But most languages would use a while loop like this. Int y equals 0, while I is less than 10, print y++. Y++ we already discussed will increment its value by 1 just after the instruction it uses is executed. So this program will write numbers from 0 to 9. They will be joined as in no space between the numbers. If you want space so it looks nicer, print y++ plus apostrophes space apostrophes would do the trick. Instead of int, we could create a variable by the type boolean or bool language dependent. Boolean can be either true or false. 1 stands for true and 0 for false in computer science. The language C interprets any other value than 0 as true. Boolean B equals false, while !false print false. This program shows how a Boolean variable is created. The exclamation mark sign in most languages means not, so not false is true. Thus we are left with an infinite loop that keeps writing false. False is also a keyword, so we won't have to use apostrophes around it. Now if we have a variable of int, does it mean we can have one of the type of an image, or let's say music? Yes. We call these objects because we call numbers and booleans primitive types. If you wanted to create an object out of your music file on your hard disk or phone, you would write something like music my fab song equals new music and in apostrophes C Mozart.mp3. MP3 is not the only music type you could use, and copyright issues might or might not arise. So OGG music type is just as good. Now you have an object, a memory representation of your song. You want to play it? myfabsong.play will do the trick probably. You could use myfabsong.stop or myfabsong.loop too.